A suspicious dog does not always look the way we expect. It may be aggressive, but it may also become unusually quiet, weak, or unstable. And when these signs appear, people face a difficult question. Should this case be prioritized for veterinary attention? Today, early reports often depend on short and subjective observations from owners or the public. Important context may be incomplete, subtle movement changes can be missed, and getting closer to observe the animal may itself increase exposure risk. This challenge was also reflected in our initial expert validation with veterinarian Dr. Alvin. From her field experience, incomplete or subjective owner information is common, and veterinarians often need additional probing about exposure history, vaccination, behavioral change, and other observable signs. This is CaniSight, an AI-assisted platform designed to standardize early observation of dogs with concerning behavior. Instead of diagnosing rabies, CaniSight combines a short video with contextual information to identify observable visual and movement indicators, then provides an explainable level of concern and a recommended next step. Existing solutions already validate different parts of this workflow. Rakon and React support digital rabies surveillance and case investigation. Triage provides AI-based symptom triage, while CityCare and Joy demonstrates AI-powered visual and movement analysis for pet health. However, these capabilities remain fragmented. CaniSight brings visual signs, temporal movement, and structured exposure and behavioral context together for explainable, rabies-oriented early screening before veterinary assessment. This is how CaniSight works. The process begins with safe and guided data collection. The user uploads a 5 to 30-second video, while CaniSight provides clear instructions to avoid provoking or approaching the animal. Before AI inference begins, the backend validates whether the video is actually usable, including its format, duration, brightness, blur, and whether a dog can be reliably observed. But video alone is not enough. CaniSight structures contextual information such as vaccination status, recent behavioral changes, bite history, difficulty walking or eating, symptom duration, and previous contact with stray or other potentially exposed animals. Once submitted, 3 sources of evidence are processed together. A lightweight YOLO model analyzes observable visual signs, a pre-trained canine pose model extracts body key points and temporal movement features. Lastly, the questionnaire provides epidemiological and behavioral context. CaniSight then combines this evidence through a transparent fusion layer instead of relying on a single black box disease classifier. For this case, CaniSight returns an elevated observational concern. More importantly, this result is not just a score. The user can see which visual indicators were observed, the movement analysis, relevant contextual factors, supporting evidence, and any limitations detected during processing. CaniSight is deliberately designed to know its boundaries. Individual signs such as aggression or salivation are not treated as proof of rabies, and poor quality evidence can return an unable to assess result. And when bite or saliva exposure is reported, safety guidance is escalated independently of the AI concern score. Our adoption pathway follows a B2G2C model. Owners and communities become the first observation layer. Veterinarians and local animal health authorities review and respond to prioritized cases. Rather than replacing Indonesia's existing animal health infrastructure, CaniSight is designed as an upstream AI-assisted screening layer, with future interoperability toward systems such as eSignas. For initial pilots, we prioritize high-burden settings identified during expert validation, which is Bali, East Nusa Tenggara, and West Kalimantan. The goal is not nationwide deployment on day one. It is to validate CaniSight with local veterinarians, test real reporting workflows, and evaluate model robustness across different environments before scaling. CaniSight, turning uncertain observations into structured evidence, so people can act earlier, safer, and with better information.